dy dx is the derivative of y with respect to x. So this is a differential equation. When you have a derivative equal to something, it's a differential equation. So it's similar to what we had before, but they're not telling us that it's an integral. They're not telling us that we need to integrate. But that's how you solve a differential equation. We need to have our letters match, so we would move our dx to the other side with all of these x's that are over here. And if we integrate dy, we're going to get y, which is the solution, and we would integrate this side with respect to x, and that's where our partial fractions are going to come into play. So we have a partially factored denominator here, but notice that this factor is not linear, and to use partial fractions, we need linear denominators, so we have to factor that one step further. This is the difference of squares. We're going to have x plus 2 times x minus 2 times x minus 1, and those are the factors for the denominator. Now, in reality, if this problem were outside of this example right here, you would want to factor the numerator and make sure that it's not going to reduce, that it doesn't have one of the same factors that we have in the denominator, because that could save you a ton of work if you reduce the fraction first. All right, so let's integrate this. Since we have three linear factors, we're going to have three fractions in our decomposition. So let's say that y is equal to the integral of a over x plus 2 plus b over x minus 2 plus, just add another letter, c over x minus 1. So our work here is, it's just going to be more work. It's not going to be any different than what we did before. If we add all of these fractions together and get a common denominator, then this first fraction is going to have to be multiplied by x minus 2 on top and bottom and x minus 1 on top and bottom. Again, we're just dealing with the numerators because we know what the denominator is going to end up being. So we have a times x minus 2 times x minus 1, and then plus b times x plus 2 times x minus 1, and then plus c times x plus 2 times x minus 2. All of those things added together have to equal the original numerator right there, 6x squared minus 8x minus 4. So a bit more work. Again, you want to choose an x for, you want every zero of every factor chosen. So if I let x be 2, then this 0 right here is going to take out this term. Notice that it's also going to take out this term right here, because that factor will be 0. And it's going to leave us just b. The other thing we want to do is let x be 1, which will 0 out this term and this term. And then we want to let x be negative 2, because that will 0 out this term and this term right here. Okay? If we let x be 2, then we're going to get, let's see, that would be 4b equals, if you let 2 be over here, then you've got 24 minus 16 minus 4, which I think is 4. And b is equal to 1. If I let x equal 1, then that term goes out and that term goes out. And for c, I have negative 3c is equal to 6 minus 8, negative 6. So c is equal to 2. Now if I let x equal negative 2, then this term goes out and this term goes out, and I'm left with negative 4, negative 3, so positive 12a is equal to negative 2, that's going to be 24 plus 16 minus 4, so that's going to be 36, and a is equal to 3. So I take these values and substitute them for a and b and c. Now the partial fractions has given me something that I can integrate, so I don't need any of this work. I'm going to move it down. Now I'm ready to integrate term by term. Again, as we saw in the last example, and this does not always happen, but in the last example we saw that if our du and our dx will be the same. If this is our u, then our dx and our du are going to be the same thing. And so the numerator becomes a constant multiple that can be moved out to the front, and I can integrate this without writing out the u substitution. I know I'm going to have 1 over u du. So the antiderivative is going to be the constant multiple 3 times the natural log of the absolute value of the u, which is x plus 2. And then I'm going to have 1 times the natural log of this u, which is x minus 2, and then plus 2 times the natural log absolute value of x minus 1. If it helps you to write out every u substitution, then do that until you're comfortable with this being the antiderivative. If there's any number that's multiplied by x, here or here or here, then you need to go through that u substitution so that you get the fix on the du and the dx. Okay, this is the answer. Notice we have a plus c because it's an indefinite integral. This may not be the way the answer looks on a multiple choice, because remember, with logarithms, and you have sums, you have properties of logarithms, so you could rewrite this in terms of a single logarithm. Before you can do that, you have to move these numbers that are out front, you have to move those up as powers. This is just properties of logarithms. So if we move those powers up, then we can rewrite this as natural log x plus 2 cubed plus natural log x minus 2 plus natural log x minus 1 squared plus c. And when we have a sum, we can multiply those things together. So we would have a single natural log, and then we could multiply x plus 2 cubed times the absolute value of x minus 2 times the absolute value of x minus 1 squared, and then plus c. Of course, if you square something, it's always going to be positive, so you could get rid of those absolute value signs right there. So you might see the answer choice written that way instead. If it's free response, then either one would be just fine. I would stop here at this one right here.